Okay, well this is Mr. Pavlovsky, and we're going to go over and do a little review of Lesson 4 from Unit 6 on the properties of rhombuses, rectangles, and squares. Some of the most important concepts are, first of all, the definitions of rhombus, rectangle, and square. A rhombus is a parallelogram. And remember, the definition of a parallelogram has two pairs of parallel sides. A rhombus is a parallelogram that has four congruent sides. A rectangle is a parallelogram with four right angles, and a square is a parallelogram with four congruent sides and four right angles. So, in essence, a square is really a rhombus and rectangle combined. Okay, so let's move on down and talk some more about some of the other theorems in this section, in this lesson. If a parallelogram is a rhombus, then its diagonals are perpendicular. So if you've already shown that all four sides of a parallelogram are congruent, then you can also conclude that its diagonals are perpendicular. In other words, this line AC, this line BD form right angles when you intersect them. The other thing you can conclude if you determine that this is a rhombus is that each diagonal bisects a pair of opposite angles. So if you look at AC, that diagonal is going to bisect the angle BAD, and it's also going to bisect the angle BCD, so that the two angles that it bisects it into will be congruent with each other. Angles 1 and 2 are congruent. Angles 5 and 6 are congruent. So the same thing holds true with the other diagonal, BD. It also cuts the opposite angles into two congruent angles, or we say that it bisects those angles. Okay, so this is a proof of Theorem 613. We're not going to concern ourselves too much with that right now, but we do want to know how to work some problems involving finding angle measures in rhombuses. So let's look at example problem 2. What are the measures of the numbered angles in this rhombus? Well, since we know we have a rhombus, then we know that the diagonals bisect each other, so we automatically know that angle 1 is going to be a 90-degree angle. What about the other angles? Well, we also know that based on what we were talking about before, where we got since we know we have a parallelogram, we've got parallel lines, and then we've got the parallel lines cut by a transversal, so that we can look at the alternate interior angles. Okay, so we want to look at the fact that these two lines are parallel, and here's our transversal, and we've got this interior angle, we've got this other alternate interior angle, so that means angle 2 has to be 58. So we've gotten these two now. Angle 3 has to be also 58 because each diagonal bisects an opposite angle. So angle BD is going to bisect the angle, the 2 and 3 are actually congruent because they've been bisected already. So angle 3 has to be 58. Alright, now we can look at this triangle piece right here. We already know angles 1 and 3, so the triangle angle sum theorem lets us find out that angle 4 is just going to be 180 minus the sum of 1 and 3, which gives us 32. Okay, so let's take a look at some example problems for you to try out. Okay, so we've got these problems here, 9 through 14, where you use the information you know about diagonals, the fact that they bisect opposite angles of a rhombus, and the fact that the diagonals of a rhombus are perpendicular to each other. So use that information to work through these problems. You'll pause it now and we'll come back and check on the answers. Okay, for number 9, all 4 of those angles are going to be equal to 37 degrees. Number 10, we have the measure of angle 1 is 26. Measure of angle 2 is 128. And the measure of angle 3 is 128. Number 11, we have the measure of angle 1 is 118. Measure of angle 2 and 3 are both equal to 31 degrees. For number 12, we have the measure of angle 1 and 2 equal to 33.5. Angle 3 is 113. And angle 4 is 33.5. Number 13, angle 1 is 32. Angle 2 is, as we know, is 90. Angle 3 is 58. And angle 4 is also 32. And then on number 14, angle 1 is 90. Angle 2 is 60. Angle 3 is 60. Angle 4 is 30. Okay. Let's go on to another concept. We're going to talk about the diagonals of a rectangle that have a special property, and that is that they are congruent. So if we know we have a rectangle, in other words, all the angles are 90 degrees, if we draw the diagonals, they are going to be congruent to each other. So if we're working this kind of a problem, and we know that, for example, SF is equal to this expression and RB is equal to this expression, we can set them equal to each other, solve for x, then substitute x back into the expressions, and we'll have the answer that 33 is the length of a diagonal. Okay, so we're going to take a look at these problems right here, 18 through 23. Pause the recording now and work through these, and then come back and we will check the answers. Okay, so for number 18, they ask you to find the value of x and the length of each diagonal. In this case, x is equal to 4. I'm going to make a little chart here. That way we can see exactly what the answers are. So for number 18, x is equal to 4, and each diagonal is equal to 4. You can check that by plugging x back into these expressions to make sure that they are equal to each other, because the diagonals of a rectangle are congruent. Number 20, we have x equal to 1, and the length of the diagonals is 4. For number 22, we have x is equal to 5 over 3, and the length of the diagonals is 29 over 3. Okay, so let's Do the same thing over here. The length of x, or the value of x, and then the length of the diagonals. So for number 19, x is 3. Length of the diagonals is 7. For number 20, x is 1. Length of the diagonals is 11. No, I'm sorry. Did I do that wrong? Oops. Gotta back up here. Okay, so for the length for x, number 21, the x is equal to 9. The length of the diagonal is 67. And number 23, x is 2.5. And the length of the diagonal, 12.5. Okay. So that should give you enough practice to do well on the upcoming test. This has been a review of Lesson 4.